You have seen the problem number 1 in the screen, which says 5,000 bacteria are growing continuously at a rate of 15% per day. Find a function that models the number of bacteria. Okay, first of all, we need to find the function that governs this entire situation of growth. And then in B, we need to find the number of bacteria after 10 days. Continuous growth function is given by this formula, Pt equals to P0 e to the power kt, where P0 is the initial value or initial number of bacteria in this case, E is the irrational number 2.718 that we discussed before, K is the growth rate, it could be positive or negative, and T is the time. Here in this case the time is in terms of days, right? And Pt is the final amount or total number of bacteria after T days. So let's go for finding out the function that models the number of bacteria. P0 is 5,000, K is 15%, which is 0.15. So that means our function would be Pt equals to 5,000, that's the initial value, times e to the power k is 0.15 times t. T is the number of days. So that's the function which models this entire growth situation of bacteria. Okay, find the number of bacteria after 10 days. So after 10 days, we'll have t equals to 10, right? Then plug this t equals to 10 in this equation, right? Which will give us p of 10 after 10 days. It would be p10 equals to 5,000 times e to the power 0.15 times 10. Okay, let us go towards geogebra.org/graphing and input the equation that you could see in the screen, which is 5,000 times and e to the power you can see shift 6, which gives us the exponent sign, shift 6 0.15 times 10, that was for 10 days. Okay, so you can recheck the equation that 5,000 was the initial number of bacteria population and E is an irrational number 2.718, 0.15 that's the 15% growth, and times 10 is the number of days. Then you can see that this is 22408.44. That's the total number of bacteria after 10 days. 22,408.44. So this is simply 22,408. That's the approximate number of bacteria after 10 days. You can see the problem number 2 in the screen, which says that world population in 1985 was 4.8 billion with an estimated growth rate to be 1.8%. Assuming the growth pattern follows this rate, estimate the population in 2020. This continuous growth with continuous rate of growth is governed by this equation, Pt equals to P0 e to the power kt. P0 is 4.8 billion. That means when it was year 1985, okay, then the population is 4.8 billion. So that we suppose to be t equals to 0. And k is the rate of change or growth rate, which is 1.8%. So in decimals, we can write it as 0.018. And time in this case is in terms of years. Okay, so 1985, that's t equals to 0. 2020 is t equals to 35. Okay, so what is the population in the year 2020? That's P35. We need to figure out the value of P35. 4.8 e to the power 0.018 times 35. And let us plug in this value in GeoGebra. Okay, now plug in the values, which is 4.8 times e to the power. This to the power is given by shift 6 and 0.018 times 35. Recheck the equation. 4.8 billion. That was the initial population in the year 1985. 0.018, that's the rate of growth per year, which is 1.8%, and 35 is the 35th year after 1985, which is 2020. Okay, and if you click enter, then you can see that is 9.0125, which is approximately 9 billion, slightly more than 9 billion. 0125 billion. So after 35 years of 1985, that is in 2020, the estimated population of the world would be 9.01 billion.